Hello friends, as we know in the last Zoom meeting, I have explained the three preparation method of the phenol. It was first one was the from chlorobenzene. It was again divided into two types, Dow's process, Reagent method. The second method was from benzene sulfonic acid. It is again having the three-step reaction. Third one was from cumene, another name is isopropyl benzene. We had not done the fourth method, so today we will discuss about the fourth preparation method of the phenol, that is from the aniline. For this method you must know what is the structure of aniline. Aniline structure is benzene ring attached with the amine group, that is NH2. When it does react with the nitrous acid in presence of NaNO2 and HCl in cold conditions to form nitrogen two times, that is known as a azo. It's a diazo. So this process is known as a diazotization group is there. It is having the two-step preparation method. In the first step we are getting, as you see in this, it's known as benzene because it's a benzene ring, diazonium because the two nitrogen is there, and the chloride, it means the chlorine group is there. So in the step number one, it is again having the cold condition and to form the two nitrogen, that is on a diazo. So this process is known as the diazotization is there. So in the first step we are getting benzene diazonium chloride with the two molecules of the water. In the step number 2, out of the two water molecule, we have to take only the one water molecule, and in presence of dilute H2SO4, then it gives the HCl as the byproduct, and main product we are getting the phenol. So in this way, this is the preparation of phenol from the aniline. So in this here, we have finished the 4 preparation method of phenol. Okay. After the preparation of the phenol, we will start with the reactions of the alcohol and the phenol. Alcohol and the phenol. So let us start with the first one, preparation of alcohol. For this, suppose litmus test. If suppose in one beaker alcohol is there, in second beaker if it is phenol is there, and if we test with the litmus paper, then what will be the result? Then alcohol, it will not change the blue litmus red and red litmus blue. It means it is neutral. It's not acidic, it's not basic. But if we check for the phenol, then it will slightly acidic in nature. It means blue litmus turns the red. It indicates that phenol, it is having slightly acidic in nature is there. Now second method, it is second reaction. This is the one of the reaction. Alcohol, it is neutral to litmus. Phenol, it is slightly acidic in nature. So it is this phenol, another name is carbolic acid. This question can be asked. Phenol, it doesn't contain the COOH group, but it is also known as a carbolic acid because this phenol, it is slightly acidic in nature with the litmus paper. Hence, it is also known as the carbolic acid. Suppose now reaction with the base. Then for this reaction with the base, this reaction, phenol, it is very weaker acidic nature. Hence, it does not react with the NaHCO3, sodium bicarbonate. There is no reaction with this. But if suppose phenol is react with the NaOH, then it is two-step reaction. In the step number 1, it gives this H combined with the OH to form water molecule. Whatever left, it is ONA. It is known as the sodium phenoxide. Now in the step number 2, this sodium phenoxide, step number 2, it is react with the HCl to form phenol plus NaCl. So this is the reaction with the base. It means the phenol, it is weaker, so it does not react with the NaHCO3. This question can be asked, is it react with the NaCO3? Then no, because it's a mild this one acidic in nature. Hence, there is no reaction with NaHCO3. But it does react with the NaOH in 2 steps. In the step number 1, with the NaOH, first step, it gives the sodium phenoxide with water molecule as a byproduct. In step 2, this sodium phenoxide, it is react with the HCls to form the phenol and the NaCl is there. So now this is about the phenol. What about the alcohol? Then as I say earlier, alcohol, it is neutral with the litmus paper, so it does not react with the NaOH. It does react with the, for example, if I take C2H5OH, it can react with sodium, for example. Then there is the sodium alkoxide is formed, so it is C2H5ONa with liberation of the hydrogen gases there. So we have to balance this reaction. This H2, this hydrogen 1. So we make it 2. Now 2, it means C2H5 becomes 2. Sodium become 2. So in this way, alcohol react with the metals. Every times whenever the alcohol react with the metals, there is the formation of the alkoxide, metal alkoxide with the liberation of the hydrogen gases there. Okay, now with the next reaction, we had already done in the halogen derivative alkane chapter, that is with the PCl3, PBr3, Pi3 or the PCl5. For example, the alcohol, any general reaction I am writing, if the alcohol react with the PCl3, then there is, whenever there is a PCl3, PBr3, Pi3, one byproduct is always fixed, that is H3PO3. And the main product, instead of HOH, it becomes the RCl is there. Now we have to balance this reaction. Oxygen is 3, hydrogen is 3. So make it 3 first. So it's a 3 RCl is there. So this is the general reaction whenever the alcohol react with the PCl3. For example, if instead of PCl3, if it is react with the PCl5, then what will happen? Then there are the 2 byproducts are fixed, that is the POCl3 and the HCl, and the main product is RCl. So in this way, alcohol react with either PCl3 or either PCl5, then it gives the alkyl halides are there. Now the next one, reaction of the alcohol with the either HCl, HBr or HI. This also we had done in the first chapter. Suppose if I take C2H5OH and if it is react with the either HCl, HBr or HI, then what will happen? Then there is the removal of the water molecule common in all the 3 reactions, and the main product is C2H5Cl. We are getting ethyl chloride. We are getting the C2H5Br ethyl bromide, or either we can get the C2H5I ethyl iodide. So 2 reactions the same as the first chapter. This we had done. PCl3, PCl5 reaction with either HCl, HBr and HI. Alcohol react to form the water molecule as the byproduct, and the main product we are getting the alkyl halides are there. The next reaction, it is with the either concentrated H2SO4 or either with the alumina, that is Al2O3. Suppose if we take the C2H5OH, instead of writing this we can write in this way also, OH. This is known as ethyl alcohol. When it is heated with concentrated H2SO4, then what will happen? This H and OH, water molecule, as the byproduct, and we are getting the CH2, double bond CH2. It is nothing but ethene is there. So with the concentrated H2SO4 or either with the alumina, we are getting the water byproduct, and the main product is the alkene we are getting if we are using concentrated H2SO4 is there. Next reaction of alcohol, it is with the Lucas reagent. Now this Lucas reagent, it is used to distinguish between the primary, secondary and the tertiary alcohol is there. So before that, first we must know what is Lucas reagent. Then Lucas reagent, it is the mixture of concentrated H2SO4 and the ZnCl2. Not H2SO4, sorry, it's a concentrated HCl and the ZnCl2 is there. Now this mixture is known as the Lucas reagent. Suppose there is the primary alcohol, 3 beakers are there, primary alcohol, secondary alcohol and the tertiary alcohol. Initially we don't know in which beaker which type of alcohol is there. And in each beaker, if we add the Lucas reagent, then this alcohol, it is the soluble, it is miscible in the Lucas reagent is there. But after sometimes when the product form alkyl halide, then alkyl halide when formed, that time turbid solution is formed. First, when the Lucas reagent added to this alcohol, that time the clear solution. But after sometimes when the reaction starts and product form, that time the solution turns to the turbid. So this turbidity we can see very immediately, instantly in case of the tertiary alcohol is there. In case of the secondary alcohol, the reaction takes place very slowly. But in case of the primary alcohol, we cannot see the turbid solution without heating is there. So in this way, Lucas reagent, it is used to distinguish between the primary, secondary and the tertiary alcohol is there. Now as we seen in the early reaction, that is the distinguish between primary, secondary and tertiary alcohol, we can do with using the Lucas reagent. One more method is that to distinguish between the alcohol from the phenol. If they ask the question, write the distinguish test between alcohol and phenol, then we do not have to write in the distinguish manner, one side alcohol, one side phenol. That is not the answer. For this distinguish test they have asked. So for that answer, we have to write the reaction with the, using the, suppose alcohol if we use, it is react with the FeCl3. If we use the neutral FeCl3, then there is no color changes there. No color changes there. But if phenol, suppose if I write the molecular formula C6H5OH, when it is react with the FeCl3, ferric chloride, then it gives the C6H5O, it's a 3 times and the Fe is there. This hydrogen combined with the chlorine and HCl is the byproducts. So this is known as the ferric phenoxide, which is violet in color. So in this way, suppose if one test tube alcohol is there and if we add FeCl3, if no color is changed, then it is having the alcohol in the test tube. In the second one, if there is violet color we are getting after adding FeCl3, it indicates that that test tube it is having must have being the phenol is there. So this is the distinguished test between alcohol and the phenol. For the phenol, we have to use the ferric chloride FeCl3. Then there is hydrogen combined with the chlorine, and for balancing this reaction, this chlorine is 3 times. It's chlorine, so it's a 3 HCl. Hydrogen becomes 3. So this is the balanced reaction is there. The next reaction of the alcohol is the esterification. Esterification, it means what? Esterification, it means the formation of the ester. Then ester functional group is what? Then ester functional group is C double bond O and O is there. So COO is the functional group of the esterification. Now in the esterification, alcohol, suppose I'm getting C2H5OH. Either it is react with the acid, or either it is react with the acetyl chloride, or either it does react with the acetic anhydride. Then in all the three reactions, the product will remain same. It is getting the CH3, COO, C2H5. In all the three reaction, the main product will remain same. We are getting the CH3, C2H5. It is known as a ethyl methyl ester is there. Either it is known as the ethyl acetate is there. Only there is the change in the byproduct. In the first reaction, water will be the byproduct is there, water molecule. In the second reaction, HCl will be the byproduct. In the first one, water molecule is the byproduct. In the second one, if we use the acetyl chloride, CH3COCl, it is known as acetyl chloride. In this, there is the main product is ethyl acetate with the byproduct HCl is there. If we use the acetic anhydride formula is CH3CO, C double bond or 2 times, and it is doubly bonded with the oxygen is there. This is the structure of acetic anhydride. In this case, there is the main product will remain same, ethyl acetate, and the byproduct is CH3COOH. It is nothing but we are getting the acetic acid is there. So in this way, we are just doing the esterification by using the alcohols are there, by using the three different reactants are there. We can add acetic acid, we can add acetyl chloride, or either we can add the acetic anhydride. Now the next reaction of the alcohol is it's very important, that is the oxidation is there. Now in the oxidation, it means there is the addition of the oxygen is there. Suppose if there is the primary alcohol is there, for example, if I take CH3, CH2OH, it's primary alcohol, and if it is oxidized, then to give the water molecule as the byproduct, H2O, and there is this oxygen, it is attached to this carbon, so CH3, C double bond O, and H is there, so to form the acetaldehyde. Now this oxidation, either we can use the PCC. What is the meaning of PCC? It means it is known as a pyridinium chlorochromate. It is known as what? Pyridinium chlorochromate. Either this reaction under the CrO3, chromic oxide also we can take, but if we use the another oxidizing agent like the KMnO4, either K2Cr2O7 or either HNO3, then this reaction, it is not only the limit of the first step. it will be continue with the step 2 also. So step 2 I'm writing CH3COH. It is again oxidized in presence of this to form CH3COOH is there. So in this way, first one, alcohol, it is oxidized to form the aldehyde. It is again oxidized to form the acid is there. So you must have to remember this shortcut method. Alcohol, it is oxidized to only aldehyde, one step. When it is possible, if there are the two catalysts are there, PCC and the CrO3, then only one step is there. But instead of this, if they use either KMnO4, either potassium dichromate or either HNO3 nitric acid, then the step number 1, it is extend to step number 2, then it forms the acid. It is known as the acetic acid is there. So here we are done. Today we have done the reactions of the alcohol. In the next session we will start with the reactions of the phenol. Okay, thank you.